Welcome to the Energy Connect studio at ADIPEC 2022. I'm delighted to have sitting next to me Tanzim Choudhury, Acid Gas Products Champion, SLB. Thank you for joining me.
Thank you very much for having me.
Now, there are several different technologies available to remove CO2 H2S from natural gas. What are some of the considerations when selecting the optimum technology for a particular application at SLB?
Okay. Now, thank you very much for the question. So with regards to the criteria, there's really three different criteria that you have. The first one is with regards to what you're trying to remove. Are you trying to remove H2S or CO2? But that really depends what technology you pick.
Yep.
And it's not just that, it's the mix. If it's a mix, what's the composition? What sort of mix is it? That's what you have to consider. The next thing is with regards to what level you're trying to get down from. So what the feed concentration is, down to what your treatment, what your specification is. And thirdly, so these are the main three, I would say. There are others, but these are the main three. Thirdly, I would say it's with regards to how much volume you're trying to treat. Now, at SLB, we have a range of different technologies available. So we have, with regards to different types of membranes, different types of amine packages, also a bio-desulfurization package, as well as others as well. So by having this range of different technologies, we're able to pick the best technology for a particular application. But often it's not as simple as that. Sometimes if you have a combination of different technologies, it can end up having a better solution. So for example, if you have a high specification of CO2 or H2S and you're trying to go down to low ppms, if you're combining a membrane system with an amine system, that essentially reduces your overall footprint, reduces your OPEX and CAPEX for many different applications. So the thing is, with the amine systems, often it's quite energy intensive. It requires a lot of pumps, heat exchangers, utility costs, and you're really able to reduce that by having an upstream membrane system in a lot of different applications. So by having that, that's what we're trying to do, trying to pick the optimum solution for the individual project in hand.
Great, thanks Tanzim. And what were the challenges operators were facing that pushed the development to advance acid gas separation membranes?
Okay, thank you for the question. So SLB have been developing membranes for the last sort of 30 years, 40 years, since the 1980s. And during that time, we've been providing vertical membranes, vertical arrangement membranes. So it's hollow fiber membranes which are made out of a cellulose triacetate material. Now, there's another type of membrane in the market which is horizontal, a spiral wound design.
Okay.
And some of those have a cellulose acetate material membrane. Now, we've heard from several different customers and operators that they've been having some challenges with those membranes. And those challenges include with regards to increased hydrocarbon loss. So you're flaring off more, you're recovering less of your gas for your sales gas. Another one is with regards to the longevity of the membrane. Okay. So if it doesn't last a long time, then you have to replace it more frequently, right? Yeah. And the third one is with regards to how much capacity the membrane has.
Okay.
Okay. So we had a lot of the different clients coming to us, and we understood that our membrane, the material itself, the hollow fiber cellulose triacetate, was able to provide some of the benefits for those challenges that the operators were facing. But the issue was our membranes were of a vertical arrangement, and those ones were horizontal, a completely different design. So that's what led us to develop the horizontal CTA membrane, taking the best parts of the vertical arrangement that we had and designing it for the horizontal application. And with that, we were able to provide immediate benefits to a number of different clients. So just to give you an example, there's a facility in New Zealand where we replaced the horizontal membranes, and we were able to reduce the emissions by 30%. And another one in Australia, we were able to increase the capacity by essentially doubling it. And you can imagine by doubling the capacity, how much, rather than creating a separate train, which you need to manufacture, how much emissions that can reduce by being able to utilize the existing unit. So that's how we're trying to, so that's why we decided to develop this membrane, and that's how it's been helping operators around the world.
Okay, well thanks for the explanation, Tanzim. And finally, how can effective acid gas separation using membranes support the implication of CCS, which a lot of people are talking about, been there a while, but obviously it's come back?
Yeah, no, good question. So, one thing I'd like to state is with regards to SLB. Now, we've been developing transition technologies, looking to reduce emissions for a long time now.
Yeah.
With regards to the change to SLB, that's really just put a stamp onto the aims and the targets that we've had. Now, we've previously done carbon capture, EOR projects with membranes, but now we're able to open up new opportunities, new projects with this new advanced membrane. For example, we're working on the largest CCS project in Malaysia, in the world in Malaysia, and that's using our new membranes. Those other facilities that I mentioned in Australia and New Zealand, they're actually able to utilize and pursue CCS as a direct result of the improved performance that they've been having with the new membranes. So in reality, we're all in this together. We're all in this sort of decarbonizing aspect together, right? And by developing these innovative technologies, by developing these low carbon technologies, we're trying to really go for a balanced planet and have a balanced future. Okay?
Yeah, that's really good to hear. And thanks, Tanzim, for giving me your time and enjoyed our conversation.
Okay, thank you very much.